Well, hello, YouTubers. Let's see what we can win today. Let's see if I can weather the channel. Let's see. I should normally do this before I start streaming. Apologies. So if I just get YouTube, get at GPL Taylor, go to X. Let's just make sure we've shouted out that we're going to start a stream. See if we can get a few people in chat. So coding, structure your projects. So let's make it have some impact. Change a keyboard to US. Honestly, gang, just live with US keyboards. It's the future. So yeah, GoLang live, GoLang coding, structure projects. So how do you structure your projects? Let's post that. Got a link, yeah. Right, so if I go over to GitHub and have a look at, just defaulted to Radius, just have a look at my projects. Just for me, let's have a look at my, should have just gone over to here in the corner. So my repositories. Hopefully the stream's okay. People in chat, if there is anyone, just let me know. I'm having a little bit of negative feedback on my mouse, which normally indicates that I have a chat problem. No one so far. Great. Hello world. What am I looking for? I actually did check it. That could be it. Did a code test a while ago for someone. I think this is it. Yeah, and it was just a simple demo, simple app of a product store. You've got some products, they've got different prices, and there's a special product price for, you know, if you buy one, you get one free, or if you buy two, you get it for 130. So, you know, if buy three, sorry, you get it for 130, or otherwise it's £50 a unit. So if you're going to buy three of them, then you're going to pay 130. And this was just a little project. But if we check out the code that I did, we have a pretty clean solution here where there's not much here. You know, you check out a new system, you then scan in, like you're at the checkout, you scan in an A, a B, and an A, and then you get the price, and then you just print that out. And most of the logic and most of the conditions are in the checkout. And you can see that's great. You've got a checkout, you've got items that you can check out, you've got a scanning tool, you've got a get. The checkout returns an iCheckout struct or object. Talked about that yesterday, I think it was. And then we just do the conditions of doing it. I think there's, is the calculator separate? No, actually, the whole calculator and how it's calculated is in this one checkout project. Now, you could, this is a simple system. You know, it's got some data so there's no database. It's just got this data with this JSON file. And there's just this checkout thing that does all of the logic. They're not even in separate files. I know some people like to put each strut in a separate file, or you know, group them together under like a DTO folder module. But here, because it was so simple, I put it all in one file. You could argue that it is still relatively clean. You can argue that, you get what it is. The only things that are exposed, I think there's even an interface in here somewhere. Somewhere it says, can't find it. There is one in there, just can't find it. I'm zoomed in so much. But there's an interface that determines, where the hell is it? Search tool would be useful. I'm just could have swore I put an interface in this thing. Yeah, just think I'm just blind. I'm blind. Was it like the top thing? Was it like the top line? Yeah. Okay. So there's even an interface that says how it should work. There's a scan and get total prices. So this thing is incredibly simple. It does one thing, it's got one thing, and you could put this into a module now and export it and make it something. You could make it so it's, importable so that you could use a checkout in your other programs. Simple. Now, this is where these micro modules can come in, where you can build these really small modules that do one job and do one job really well. And if you do that, does structure and architectural patterns matter? Do you need to structure it in a certain way with a certain folder structure and a certain set of parameters, and ensure that you've got all things in internals and package folders and things like that? Technically, I would say yes, from an architectural point of view. From a reality point of view, people don't do it because it's quicker and easier to just bash out the code in one file and get it out there and get it tested. I am for both things. I love to be able to get code into UAT as quickly as possible, for people to touch, feel, and play about with, and express themselves through what they see already. Dead easy for people to be able to look at something and go, nah, I don't like that, or could you make it do that? It's almost impossible for people in meeting rooms with a whiteboard to spec out what it should do, and then go and do some UML diagram and say this is how it should work, and then the developers build it, goes back to the user, and they go, this ain't what I want. This is actually counterintuitive, and also gets in the way and inhabits me, or stops me, whatever the word might be, from making a deal or selling or allowing the business to make money in the optimal way. Well, there's a sweet spot between getting something out there and getting something done. And that's where things can be problematic, is as soon as the developer's got something out there that looks like it works, product owners want to race and run ahead. And if you just write your code like this from day one and just get it out there, you've got to worry then that your product owner might just turn around and say, right, let's move on to the next ticket. This is good enough. And therefore then there's the over engineering side, where developers, create this crazy structure where there are objects that have DTOs, that have factory patterns, that have adapter patterns, so that at any point in time you can change any product or any kind of implementation of this. There's this rule here that's just in this JSON file that would actually become pulled in from some, multi-clustered Redis server, and developers can then really over-engineer. So there's a sweet spot between getting something out there that works and is usable and clickable to get feedback, then getting the project into a state that's maintainable and stable. And that's the key, is when somebody comes back to this in a couple of months' time, a year's time, and they want to make a change to it, how easy is it? Well, we got some tests. We've even got a benchmark. We've got this craziness that's testing different products. And this test isn't fit for purpose because this test is just testing value for value. If I buy this, this is the cost. But it's not really testing the actual implementation. So these tests are brittle. There's a nice benchmark that tells us, you know, this is how fast it was. That's pretty cool because we're now able to make sure that the changes that we do aren't causing negative impact. So that's awesome. So all in all, this is relatively clean to maintain and update. Just complexity is small. But that's not the reality of projects as they grow. Especially like APIs where there's a lot of logic in the app itself. It's not an API, it's the whole app, if you like. You know, if you're creating some kind of e-commerce system, all of the code sits in that one project. They might be in different packages, but it's still in one great monolithic application. And in some cases that makes sense. So if we have a look at just one, and I'm going to Radius because I think it's a good example. Well, if we have a look at Radius, we can see we've got the different projects for command. Well, build, where our assets go, I think. Nothing, just go and check it for yourself. But build is where all the build assets go, where you find the actual final binaries of these things. Commands are the commands that you're going to build. So if you've got an app called My Amazing App, that's the code there for the first executable, if you like. And that would either be your API, so the endpoints, or it would be the actual real commands that you would type in on the command line to make it do something. Now, I'm not going to go through each one because I just want to show you something. But if I have a look at this one, is packages. Here's a list of packages. The idea is that I should be able to use any of these packages in my projects. And that sounds interesting, doesn't it? So if I want to have a look at Kubernetes, I could pull into my project this Kubernetes module and get access to the things that it does. Now, looking at it, it actually doesn't look all that impressive, but let's have a look. Let's see if there's anything in there of use. And particularly what you'd be looking at is trying to find anything that's public. So I'm not going to go into this in any detail, but that's a bad example, right? I've gone into Kubernetes, and although it's in a package in a public system, there's nothing in there that I could use inside of my project. And that's what you really should be doing with your packages. You should be thinking of them as external assets, not just stuff for your project, but imagine anybody in the world could pull that down. Now, I came across, as I was searching and playing about with this and trying to get an idea of what good structure should look like, came across Elder, very new, only a few subs, only a few videos on there. But one of the videos that she does have is how to structure your projects, which I highly recommend you go and have a look. Yeah, my video is going to go a bit wonky because my computer's rubbish. But she talks about project structure and what should that look like. And there was a great reference out to this GoLang standards project. And let's have a look at that. Let's dig into this a little bit more. But what this is a project, like a template, if you like, that you can start your project off with. And I'll let it cook and I'll tell you what I think at the end. But we've got a couple of these projects, and I think there is a good README. So this is a basic layout for Go application projects. Note that it's basic in terms of content, because it's focusing only on the general layout and not what you have inside. Makes sense. They're not wanting to subscribe you to, some CRM, some content management system. God, I'm trying to think of a couple of names, but you know what I mean. GoLang and things like that. They're basically working on the structure only of the project. I like that. It's also basic because it's a very high level and doesn't go into any great detail in terms of how you can structure your project even further. Extendable, implementing. It doesn't try to cover the project structure you'd have with something like clean architecture. Oh, I might go into that at some point. Vertical slices, clean architecture. And this is not an official pattern or anything that's designed by the GoLang team and the GoLang community. This is kind of just something that is a sideline. But it is a set of common historical and emerging project layout patterns in the Go ecosystem. I like that term. This is I love this because we've looked at the community. We have looked at what other projects are doing and how other projects are structured. They have then took the commonalities, the things that we're seeing and the layouts that we're seeing in all of these projects, which I think is really cool. Some of these patterns are more popular than others. It also has a number of small enhancements along with several supporting directories, common in any large enough real-world application. That's a good term. If you're making these little standalone apps and you're learning Go and you're playing about with Go, see if I can get a bit more light on me, and you're playing about with these projects, then you're never going to get your project to a size that you're going to get in real life. Every month, every 2 weeks even, developers are adding and adding and adding more features onto a project. You might have a team of maybe 4 or 7 developers all adding code all the time, almost every week, almost every year onto this project. That thing, it grows like a monster, absolutely just balloons. And before you know it, you can get yourself in a stalemate where you can no longer add anything onto that project because of technical debt or because of complexity. The two different things. And at that point, you're in a real bad situation. But if you can start off, this is so difficult, but if you can start off your very, very basic project, you start up and you can start it in the right way and enforce a way of working and a pattern of working. Because Go lets you just put everything in one file, right? It just does, and that's great for learning. But terrible, as my initial one, great for the first one, but absolutely terrible once you start having something that's living anything over 6 months. There's a huge amount of code that can be generated in 6 months. So I like this. Note that the Go team provide a great set of general guidelines, about structuring Go projects, and organizing Go modules. There's a great links out to how they manage internals. It includes internals and directory patterns, and we're going to describe that below, and useful information. So if you're trying to learn Go, or if you're building a proof of concept, or even just a simple project for yourself, this project layout is overkill. Yeah. You have to start with something simple instead, like just a single main file. I promise I didn't read ahead. I promise. It's true, isn't it? When you start off with you're trying to learn something, you want to take away distraction. You want to take away all of the extra context that you got to keep in your brain, all the extra things that you normally have to think of when you're developing a real live application that's going to go into production, that people's mortgages are being paid by. You've got to be a bit more careful than, haven't you? But with this, when you're learning, you just do, mod in it, new project, main, bing bang bosh, put your stuff in, run it. That's fine. But I also think that you should really spend some time building these projects and trying to work out how to put stuff in. Because the context problem of where the hell do you put stuff? Where should my new struct go? Or I'm going to call it a class. Where should this new module go? Where should this new feature go? How should it be used? How should I expose it to the rest of the program? If I was to give a bit of advice at the moment about this, the way I would think about it is think about it from a third party's perspective. Another developer on the other side of the world who's imported your project and is trying to use it. They're trying to make calls with it. And developers generally don't think that way. Developers think about feature. Does it work? Does it meet the obligations of the product owner? Story, the proof of concept, that whatever, the agile stories that you'll have done, does it meet them, given when then and all that stuff? And will it pass acceptance testing? And the code is all in one file, it's all public, everything is exposed, uppercase letters, the lot, there's no internal, there's no package, because they've not thought about what happens if a developer goes, use it, import this, and imports your package, your code. How do they interact with it? And even if a developer's not doing that on the other side of the world because you have no intention of ever sharing this code, and that's fine, still think about it that way, because other developers are using your code. Other developers are going to use your logger or your database tool or your ORM or your call to see what the prices are for a latest product based off the current conditions, and think about how they would interact. The example I showed before, the very silly one, although the code was crap, there was an interface there, and people would only get an interface back, and there was clear patterns about scanning getting a checkout item, scanning it and getting the product, and a developer would not be able to do anything else with it. They couldn't jimmy the figures, they couldn't create a new one that was unable to work. They couldn't instantiate a new struct that just simply didn't work. There was a pit of success, which is, doesn't matter what the developer does, but they fall into using it correctly, instead of the other way around, where they fall off the cliff and die. And you're allowing them to make breaking changes because your code is allowing them to go down a happy path. The happy path should be kind of that. A happy path should be developers fall into a pit of success, because no matter what they do, they can't climb the hill to get access to things that they shouldn't, and the calls that they make are documented and well understood and easy to understand. And you haven't got anything where you've got to call this, before that. The pit of success is cool. Anywho, these projects allow for that. Structure your projects in this way makes you do it. So this carries on talking about important. Right. Here we go. With Go 1.14, Go modules are finally ready for production. Using Go modules, unless you have a specific reason not to use them, and if you do, then you don't need to worry about Go paths. And where you put your project. Oh my God, I'm not going to get into it. There's many videos about it. If you don't know, you're so lucky. The basic Go mod, files in the repo, and assume your project is hosted on GitHub. Using that. But it's not a requirement, of course. Module paths can be anything, though the first module path components should have a dot in its name. The current version of Go doesn't enforce it anymore, but if you're using slightly older versions, don't be surprised if your builds fail. Yeah. Project layout is intentionally generic and doesn't try to impose any specific project structure. So let's get into the meat, shall we? We have a /cmd command. So the main application for this project. Now this, in my opinion, is the main for APIs or command line interfaces or whatever. It's a series of commands, and your program might have 20 different executables that are all being built from this, and that's fine. So you put all your stuff there. We'll look at a real one. If we have a look at command, I think this one is using Cobra. Cobra! And it's using that to build applications. So we see we've got a couple. The controllers, Kubernetes, docgens, a RAD app, and a UCP for control plane. And if we look at this RAD, it's your bread and butter Cobra import. So we do the export, we then have the commands in here, which then has a list of all the things that you do, and inside there is a list of commands that you can do, and we just add them up and do them. So we could do Cobra command bicep, it runs this, and then it runs this bicep command. So all pretty simple stuff that will then link in the root. So if we link in the root, we can see then that this is a list that's taking all of things from our packages file and linking the command to a package. So we get this separation of here's a list of commands, here's how the app interacts, and that's great whether API or command line, you get inputs and outputs, but then you can have a clear separation between that and the code that actually runs. That is super, super, super useful. And not only does it help get away from like Git conflicts and complexity, it just makes your code nicer to work on. As a developer, you just feel that your context has been taken away. I know that bicep is going to run this bicep command. I now know exactly where this code is. I can just go to this module now, which is in packages, CLI command bicep publish, and I can just go straight to it. I don't need to know anything. I don't know what vast majority of these things do, but it's almost intuitive that, you know, we've got a receipt for a command for the CLI, which is going to register a receipt. Well, I know recipes, sorry, they're just a way of getting assets into Kubernetes or other control planes. So I know that's just a way of registering your recipe into the engine. I don't need to know a great deal about it. I can naturally, intuitively see. And of course, this is one great big root. I would have split this up by domain context, understanding the business, understanding what we're trying to do, maybe grouped together all recipes into a separate file, and all things about the environment into a separate, and grouped it, you know, subdivided it up a little bit. But we've got the / command bit, which is cool. Internal. I don't think internal is used within Radius. Let's have a shufty look. But internal is, I believe, it's a built-in GoLang thing now, a new thing, where any modules above the path can't access it. So you imagine you have got folders within folders within folders. You can only go down, can't go up. If you used to React, if you have props, you can only go down. Then props can only go down into the children, and the prop can't just go and mess with a parent component. Live the analogy is there to keep it simple. I know there are ways to hack that, but the ideas sound right. It's you can only go down, you mustn't go up. That includes people using your project as well. So private applications and library code is where you would put stuff into internals. And this is the code you don't want others importing into their application or library, or even a developer working on the same project. So I think I read a little bit down on this because there was something I didn't quite get. No, maybe it's further on. I think there was a thing like, let's have a look. Sure, there was an example that was like A, B. No? Oh well, I must have been reading it from somewhere else. There was an example that showed A, B, C, D, E, F, G, and that if your internals were at the middle, then you could only access E, F, G, and A, B, C wasn't acceptable, wasn't accessible. Right, packages. This is the meat and potato, isn't it? Library code that's used by the internal application. So for instance, package my public lib. Never name things that. I've done that. Class CLS, class pro, export utilities. I think naming's hard, right? But you're better off calling something super green elephant rather than class libs, my struts. I mean, good God, don't do it. Don't code. Just keyboard, turn it off, walk away. You're better off doing that than naming something class lib. No. Apologies to all the developers who are still working on the code that I named class lib, general export, my tools, struct pros was another one. Just don't do it. The package directory is still a good way to explicitly communicate that the code in that directory is safe for use by others. So I'll take package over internal blog. Oh, that's worth a read. By Travis provides a good overview of the packages and internal directories and when it might make sense to use them. So that would be a good read. /vendor. You're going to know this if you're doing web dev. It's all of the vendor packages that you want to import. So application dependencies, the go mod vendor command will create a vendor directory for you that you might need and flag your go build commands are not using go 1.14 where it's on by default. Don't commit application dependencies if you are building a library. Yeah. Not for you. You don't include them in Git. We don't need executables in Git. We don't need passwords in Git. Listen, we don't. Secrets. No. Not where they live. There's a reason for it. Note that since 1.13, Go also enables the module proxy for features using proxy.golang. That's it. As their module proxy server by default. Read more about it. Wow, since 13. Okie pokey. You know, every day is school day. /APIs, open documentation. I think this is the docs, I think. So open API, Swagger spec, JSON schema files, protocol definitions. Yeah, that could be confusing, but /API is not where you're putting your API endpoints. It's where you put in all of your assets that you might be using to build up your API. As it says, JSON schemas, open API documents, Swagger, which is all documentation for API endpoints, goes in there. /web, it's your website. Simple. Config is config. Init. System init, startups, services, and process management supervisors. Run it, supervisor Ds. Okay. So if you're doing anything definitely overly Linuxy, where you're wanting to run something as a background daemon or as a service, then you could put your configuration in an init /init folder. That's what it's a guess. It's what I'm guessing. I've built a lot of services that are background workers. You know, as soon as the Linux operating system fires up, it runs its system D, starts running this program, and they run. Kind of not in that world anymore now. With everything being Dockerized and everything just running in containers, these things are just running anyway. Pod fires up, service starts as default, and the app runs. So I'm no longer in a situation where I've got to manage a cluster of Linux servers that have all got these background daemons that are running, and I've got to monitor them and restart them if they fail. Oh god, them days were hell. Them days were absolute hell. Gone, thank God. /scripts, obvious. Any kind of self-serving scripts that you may have. You find that there are things that you're doing over and over and over again, outside of like your make file, like building and stuff. But there might be things that you do, like making sure things are lowercased in certain files, make sure that you've linted certain things. You could put all of them inside scripts. There's an argument, it even says, these scripts keep the root level make file small. Yeah. I mean, if you've ever worked on any kind of C# C++ stuff, the make files just start to get unbearable. I mean, you're not going to pass probation by the time you've finished reading the bloody make file. It's just, so splitting them out makes them, it's weird, isn't it, that splitting them out doesn't make them any smaller, it just moves them. But for some reason, it makes it in your head that it's easier to understand. When you see a 10,000 line make file with what appears to be every object under the sun imported in some variable lookup condition, God, it's not to want you to slap you across the face with a wet fish. Build, packages, and continuous integration. So we put in CI scripts in the build. Is that what you mean? So put your cloud, containers, Docker, debs, packages, configuration, and scripts in packages directory. All right, okay. Well, I've always thought that your build's completely ignored from Git. You know, that's the way I've always thought about it. That when you look at build, that's all just stuff that's being built afterwards. Maybe I've got this the wrong way around. So put your CI circle, mentioned circle, nice, configuration and scripts in build CI directory. Note that some of your CI tools, like Travis, are very picky about the location. Very picky. We need a higher term. Try putting the config file in build CI directory, linking them to the location where the CI tools are expected. Yeah. Or just use Ergo. You know, just solve all problems and use Ergo. Deployments, LAS and PaaS and systems and container orchestration, deployment configuration and templates like Docker Compose, Helm and Terraform. Oof. Note that some repos, especially apps deployed with Kubernetes, this directory is called deploy. So yeah, do you know what? I prefer deploy over deployments. I don't even understand the difference from an English grammatical sense. But for me, deploy is how I'm going to get this stuff out. You know, that might be a list of Helm charts that are being managed then by Ergo, which is pushing it out. It might be old school and have a lot of that as terraforming ecosystems and infrastructure, which then some pipeline somewhere, Circle CI or something, or Travis is building and deploying. But that means that all of your apps have got their own deployment system, and it's the developers that are responsible for configuring Helm. Depends on your team, but I like that because it means that developers can build their own Minikube or whatever, and they can run it using these scripts. And then when it comes time to deploy it, we deploy, and Ergo can scan these directories and then just push them out. So easy, so easy. Because developers have been dog fooding it, so they've been developing it and releasing it and support and building it internally using the exact same scripts that are then going to actually just deploy it on a different Kubernetes system. Awesome. And then of course tests and docs, tools, examples. For the love of God, put examples in, even if it's just a one-liner. Please just show people how to use the system and code that you've built. An example in code is worth 1,000 meetings, because every developer can recode. So every developer can look at your example files with a little README that explains what it is and understand it in seconds, compared to, you know, maybe technical docs which go a little bit too far. Third party. External helper tools, fork code, and other third party utilities. How does that differ from vendor? I don't know. Vendors, you're going to use import tools to get the vendor packages in. You're going to use Go vendor to pull them in. Third parties, like I think the thing here is where it says forked code and other third parties. So I've had this in the past where we've had as a team a bug with some third party, and it's a real bug. We've identified it, we've done a PR, we've sent it out, and for some reason or whatnot, we've just not been able to get the PR over the finishing line. But we've needed to have that code. So in that condition, we did it with a .NET project. At that point, we had to take the NuGet out and actually import all of the code. But the code was imported into just a folder. So we had, let's say it was like project A. We had project A, tool B, project A, tool C. Nobody knew that this was a forked bit of code that came from this other project. And after a while, when the project was fixed, the work was never done to take that out and to turn that then back into a module. So we weren't getting the benefits of the updated NuGet packages. We had this stale code now. And it was only when a scan was done and there was just a warning. It wasn't anything severe, but there was a security warning on one of the dependencies that we realized, where's this even come from? You know, the developer had long gone, and we're thinking, where the hell did this come from? And more to the point, what do we do now? Do we take it out and try and import the real one? Do we try and because it was a full fork commit. It wasn't, and we only needed like 3 or 4 of these structs. We only needed a little bit of what the actual whole project did. So should we just take them bits out and rewrite them ourselves, even though it was quite complex code, mission critical complex code? That was a mistake, right? We should never have done that. Third parties make that explicit. It makes it crystal clear to the developers who are working on this project. Be careful. We've imported this for a reason, but that should come with documentation to explain why you've done that. Git hooks, everyone knows. Assets. Is this like image? Yeah, images and logos. So useful, so useful. We have an assets module that you can just import that just has SVNs and images and colors and CSS and themes for the business. So whenever you're starting a new project, you can just do, new Go mod in it, and then straight away pull down this mod. You've now got access to loads and loads of goodness that allows you to then build the website that's part of it that makes it look like the general theme. Best thing is, our design team said we're going to just, tweak or something. We can update the CSS, release it to the asset, rebuild all the systems, and all the websites change. So, we have a system at the moment. It's not big. It's about 200, maybe 300 systems. We can just update them in minutes and push to UAT, push to prod. And it's a developless process. In other words, no developers harmed in the releasing and updating of assets, which is pretty cool. Source, magic, isn't it? So some Go projects do have a source folder, but this usually happens when devs came from a Java world where it's a common pattern. If you can help yourself, try not to adapt this Java pattern. You really don't need your Go code or Go project to look like Java. Java mentioned. Come on, Prime. You got to do one on this. So yeah, we know it's code, right? We that's what we're writing, but we don't need to call it source. However, in defense of Java structure, the /source allows you to then know that that's where your source code is, but it also means that your source code isn't in the root of the repository. That's a big thing, because if we want to move that away, and we want to move it with all the history, it's easy. If we want to add documentation, well, it's just /doc. If we want to add assets, it's just /assets. And we're not going to pollute. It sounds weird, but we're not going to pollute where the code lives. We're going to leave that alone. And in the mind, that makes a big difference. So I defend the idea, just maybe source was a little bit too geeky. A bit like class libs, class pro structs. Don't do it. Honestly, name your systems Titan Panther green, or Cobra iron purple. An animal, a metal, a color. Put them together. There's your name. Just do that rather than source. Class monkey. So that's it. There's a couple of other things. I think there's some good links in here as well. It's well worth a look through. It's well worth watching that video as well. I'll put that in the chat. I'll put that in the comments. So thank you very much. Let's have a look. Let's see what we're doing. Any chat? No? Great. Perfect. Thanks. Awesome. Why is my keyboard not working? Why is my keyboard not working? Where are you going? Where are you going? Why are you going over there? Where are you going? Where are you going? Come back. That's it. Dearie me. Let's have a look at this. So as always,